Hi, welcome to my channel pibyme Maths. This is by WST02. Here we are solving January-February 2020 Statistics 2 paper. Let's look at question number 1. Flock Car is a car hire company that allows cars to be hired for single days. The number of cars hired on a different days are statistically independent. The number of cars hired on a randomly selected day can be modeled by Pearson distribution with mean 4. Calculate the probability that exactly 6 cars are hired on a randomly selected day. So we can write x follows, the lambda is 4, Pearson distribution of 4. So they want us to find x is equal to 6. Just use the formula e to the power minus lambda, lambda to the power 6x over x factorial. E to the power minus lambda times lambda to the power x over x factorial. 10419 0.10419 dot dot dot. We can round it to 3 significant figure. Part B now. Calculate the probability that on 2 randomly selected days, the mean is 4 per day, so when you multiply by 2, lambda is going to be 8. The total number of cars hired from Flock Car is between 3 and 7. So we can write y follows Pearson distribution of 8 here. They want us to find between 3 and 7. The 3 and 7 are included. So when you split it, you can write it as y is less than or equal to 7 minus, we need 3, so we can subtract till 2. So let's get the table values for lambda is equal to 8 and x is 217. Okay, lambda is 8 here, x is 2. Is 0.138, 7 is 4530. So 0.4530 minus 0.0138. 0.4530 minus 0.0138. 4392, 0.4392 is answer. Part C now. Use a suitable approximation to find the probability that on 7 randomly selected days. So for 7, lambda is going to be 7 times 4, 28. The total number of cars hired from Flock Car is more than 30. So for Pearson, we use normal approximation. So we can write C follows just another variable n of lambda comma lambda, where mu is 28, sigma is square root of 28, and they want us to calculate C is more than 30. Since it's a discrete random variable and we change it to continuous, you need to apply continuity correction. So more than 30 is same as more than or equal to 30.5. And then apply standardization of normal distribution. Z is greater than or equal to 30.5 minus mu over sigma. Let's calculate this now. (30.5 minus 28 over square root of 28). Round it to 2 decimal place, that's 47. So P of Z is greater than or equal to 0.47. The area on the right hand side of the point 47 will be same as 1 minus the left hand side area, right? So that we can use the table value. (0.47), the value is 6808. So 0.6808, you will get 0.3192. That's the answer. Part D now. The probability that a car hired from Flock Car is returned in good condition, P of G, let's call it P of G, is 0.97. In a randomly chosen period, Flock Car hires out 100 cars, so N is equal to 100. The probability of they are returned in good condition is 0.97. Part DI. Explain why the distribution of the number of cars returned in good condition would not be well approximated by Poisson distribution. We apply Poisson approximation if n is large, p is small, but here p is equal to 0.97 is not small. So if you ask me then which number is small, usually if it's less than 0.1 we consider it as small, around that value, but 0.97 is not small. Now double I now. By considering the number of cars hired out that are not returned in good condition, so P of G complement is 1 minus P of G is 0.03, right? 1 minus this value. Use a Poisson approximation to estimate the probability more than 95. So lambda is NP, which is 100 times 0.03, you will get 3. So we can just say J follows Poisson distribution of 3, and they want us to calculate J is more than 95. Wait, here they say estimate the probability that more than 95 cars hired out are returned in good condition. But we are taking the probability of success as they are not returned in good condition. Why we are taking this probability? Because this probability is small, so you can apply Poisson approximation. So if more than 94 cars are returned in good condition, the cars that are not returned in good condition will be less than 4, right? 4 or less than 4, right? Because more than, let's say, 96 cars are returned in good condition, then 4 are not returned in good condition. So it should be 4 or less than 4. So we just take the table value for lambda is equal to 3, x is 4. So lambda is 3, x is 4 is 8153. 0.8153. So that's why you have to read the question carefully. Okay, you cannot take this probability and apply Poisson approximation because the probability is not small. So you cannot apply Poisson approximation. That's why we take P of G dash, and then the number of cars given here are written 95 or written in good condition. So you don't use the number 95, you use 100 minus 95, which is 5, but they say more than 95. So less than 4 cars are not returned in good condition. Question number 2. Duck eggs are classed as large or small. Kiyoshi knows that 35% of the eggs laid by his ducks are classed as large and the rest of them are small. The eggs are randomly allocated to boxes each containing 6 eggs. Okay, so N is equal to 6. P probability of large is 0.35. Large eggs. A box is selected at random. Calculate the probability that this box contains exactly 2 eggs. So P of, okay, we need to write the variable. X follows binomial distribution of 6, 0.35. So for I, we need to find P of X is equal to 2, which is 6C2 P to the power 2, Q is 1 minus P to the power 6 minus 2. So let's calculate this. 6C2 is 15 times 0.35 square times 0.65 to the power 4. 0.328. Double I now. Find the probability that this box contains more large eggs than small eggs. There are 6 eggs. So if you put 3 large, 3 small, they are equal. So the large has to be at least 4, right? Then only it will be more than small. So you need to find x at least 4, which is 1 minus x is less than 4 or less than or equal to 3. Now we are going to use the table value. We need to look for a binomial cumulative table with n is equal to 6. Probability is this, x is equal to 3. So n is 6, probability is 0.35, x is equal to 3 is 8826. So 1 minus 0.8826, so the answer is 0.1174. That's all. Let's move on to part B now. He or she believes that the portion of large eggs are produced by the ducks will increase if he adds a supplement to the duck's food. To check his belief, he takes a random sample of 50 eggs, so n is equal to 50. After the supplement has been added to the duck's food and finds that 25 of them, that's the observed value. Use a suitable test with 5% significant level to determine whether or not there is evidence to support he or she's belief. State your hypothesis clearly. It was 35% large eggs, right? Now he believes that if he adds supplement, the probability will be increased, right? So we write, assume that H0 is true. So we can write y follows binomial distribution of 50, 0.35. And the observed value is 25. It's a one-tailed test, so we need to calculate y is greater than or equal to 25, which is 1 minus p of y is less than 25 or less than or equal to 24. So value of n is 50, p is 0.35, x is 24. Okay, 50 is here, 0.35 is here. 24, do we have 24? Yes, for 24 it's here 9793. 1 minus 0.9793 is 0.0207, which is less than the significant level. So always remember this, when the calculated value is less than the significant level or the observed value lies in critical region, these are all the two conditions where we reject H0. Always remember this. So in this case, the calculated value is smaller than the significant level, so we reject H0. That means we are going to accept this. So there is, you need to write this line, there is sufficient evidence to support he or she's belief. Or you can add he or she's belief that the large eggs produced by ducks will increase. So you need to write that line, otherwise you will lose a mark. Okay, next, part C now. He or she sells boxes that contain more large eggs than small eggs. So the probability for that is, we calculated it here, 1174. 0.1174, right? So he's selling the box for a profit of this and the rest of the box for the profit of this. Okay. The proportion of large eggs produced by he or she duck has increased to 45%. It was 35% here, right? Now it's increased to 45%, and the cost of the supplement, because he is adding a supplement, this per box, given that the eggs are still randomly allocated at box. Explain whether or not he or she should continue to add the supplements. Okay, let's find the expected profit for both scenarios. For the first one here, the expected profit is, okay, first we write this and then the expected profit is equal to this probability times, because the box contain more large eggs are sold for a profit of this 1.20 plus the rest of the box are sold for this amount. Rest of the box means 1 minus this probability, right? Because this probability is for the boxes that contain more large eggs than small eggs. So the rest of the boxes is 1 minus this, right? Times 0.60. That's the expected profit before adding the supplements. Okay, 0.1174 times 1.20 plus 1 minus 0.1174 times 0.60. 67044. 0.67044 is the expected profit per box. Now let's find the expected profit per box with this scenario, for this scenario here, where the probability is 45% and then there is a supplement cost also. Okay, here the probability is 0.45. There are 6 eggs in a box. We need to find out what is, okay, this is, let's say we take L follows binomial distribution of 6, 0.45. What are we doing if there are more large eggs than small eggs? What would be the probability here? Because in the previous scenario we used this probability because it says the boxes contain more large eggs than small eggs, right? So the probability is the same, so we use the same as this one from part A. From part A there are 35% and 6 eggs, so we have taken this probability because there are 35%. We used P as 35%, right? P as 35%. But now in the question the P has changed actually to 45%, so we need to calculate this again before find the expected profit, which is 1 minus P of L is less than or equal to 3, which is 1 minus, let's get the table value for N is 6, P is 0.45, X is 3. Okay, N is 6, P is 0.45, X is 3, 0, 1, 2, 3, that's 7447. 0.7447, so you will get 0.2553. That's a probability for the boxes that contain more large eggs than small eggs. Okay, now let's find the expected profit. So you have to pay attention carefully here. They sold these boxes, the boxes with more large eggs than small eggs, for 1.20, right? That's what given here, 1.20, and the rest of the boxes for 0.60. So rest of the boxes means 1 minus 0.2553. That's a probability that the boxes contain more small eggs actually, times 0.60. Okay, that's a profit per box, but again you need to subtract this supplement cost, because for every boxes he is spending this many for the supplement, right? So you need to subtract that amount and find the expected profit now. So 0.2553 times 1.20 plus 1 minus 0.2553 times 0.60. Get this value, minus 0.1. You get 0.65318. So what we are doing here actually, we are finding the expected profit before adding the supplement, and we got the profit as 0.670, right? 0.670 before adding the supplement. After adding the supplement, it has reduced actually, right? So it makes sense. Adding supplement is not increasing the expected profit, right? So you need to write the conclusion actually. You need to write 0.65318 is less than 0.67 the previous value, 67044. Therefore, he or she should not continue to add supplement because that's not increasing his expected profit. So you have to write the conclusion at the end. Question number 3 now. A task was designed to take a person 25 minutes to complete. The random variable t represents the time in minutes it takes to complete the task and is uniformly distributed over this interval. Okay, so we can write t follows uniform distribution of 25 minus k, 25 plus 3k. I'm gonna draw a diagram here. 25 is here, this is 25 minus k. It says k is a positive number. This is 25 plus k plus 2k, 25 plus 3k. Let's assume the y-axis is here. We don't know where the y-axis is because if k value is more than 25, it's going to be a negative number. So y-axis will be somewhere here actually. So it doesn't matter. This is just for the reference, f of t. This is t. So the function is, if you draw the function, it's 25k to 25 minus k to 25 plus 3k. This will be 1 over b minus a. B minus a, when you subtract 25 will be cancelled. 33k minus of minus k. So you're going to get 1 over 4k, right? So when they ask you to find the probability of 25 minus 0.5k to 25 plus 2.5k, let's say 25 minus 0.5k is here, 25 plus 2.5k is here. They want this area. So the length between these two is 25 plus 2k minus 25 minus 0.5k. That's the length times the breadth of the rectangle is 1 over 4k. So 25 will be cancelled. You'll get 3k over 4k is just 3 over 4. That's all. Just a 1 mark question. Part B now. Given that e of t square is this, find the value of k. Okay. We know t follows uniform distribution of 25 minus k, 25 plus 3k. And for uniform distribution, the expected value, there is a formula given in the data booklet. It's b plus a over 2. So it's going to be 50 plus 2k over 2 is 25 plus k. And then there is a formula for variance of t also, which is b minus a. These formulas are given in the data booklet. Whole square over 12. B is 3k. Okay. 25 will be cancelled. You will get 4k whole square, which is 16k square over 12 is 4k square over 3. So we can write variance of t as e of t square minus e of t whole square, right? Sub in all the values here. 4k square over 3 is e of t square is this 918.76 minus e of t whole square. So expand the bracket and simplify. You'll get a quadratic equation. Solve the quadratic equation, get the value of k. Okay, first thing first, I'm gonna get rid of this Okay, never mind. I'm gonna write it as 4 over 3. 4 over 3 is a recurring decimal. So let's multiply everything by 3 first. 4k square is equal to 3 times 918.76. 2756.28 minus 3 times 25 square 2ab plus k square. Open the bracket and simplify. Minus 3k square, bring it here, you will get 7k square. And then minus 150k comes here, positive 150k. So this minus 3 times this value minus 3 times minus 3 times 625. You get 22032. That's positive, comes here negative. 881.28 is equal to 0. So k is minus b plus or minus square root of b square minus 4ac, everything divided by 2a. Now let's use the calculator to get the value of k. 53750 minus 881.28. You get 4.8 comma. Okay, the next one is a negative number. Negative 26.2, etc. And the question clearly says k is positive, right? So we can write therefore k is equal to 4.8. That's all. Let's look at part C now. A task to be completed by 50 people, assuming that the people complete the task independently, and they want you to find 20 out of 50. Every people are completing the task are independent to each other. It's a binomial distribution, right? N is equal to 50. Now what is the probability of success here? Probability of success is 20 of these people complete the task in less than 25 minutes. So we need to find t is less than 25 minutes first. So I'm gonna put the graph here first. Okay, this is the graph actually, right? What would be p of t is less than 25? Look at the graph. There are 4 equal portions, right? This is 25 plus k, 25 plus 2k, 25 plus 3k. So less than 25, this area, right? If you want, you can just use the normal method actually. You can, that's just 1 over 4. You can straight away write it as 1 over 4 or write it this way. T is less than 25 is 25 minus k, that's the length of this, times the breadth is 1 over 4k. So which is k over 4k is 1 over 4. So it's a binomial distribution of 50 comma 1 over 4. They want us to find at least 20. T is greater than or equal to 20, which is 1 minus t is less than 20 or less than or equal to 19. So 1 minus, get the probability of n is equal to 50, p is 0.25. You can write it as 0.25 if you want. 0.9861. So when you subtract, it's 0.0139. That's the final answer.